What are wind farm support vessels? Offshore Wind explained. Offshore wind farms have become a central part of the renewable energy landscape, generating large volumes of sustainable electricity by harnessing strong winds at sea. Located away from coastlines, they benefit from more consistent wind conditions, enabling efficient large-scale power production. This creates the need for specialized support. Wind farm support vessels play a critical role in construction, operation, and maintenance, ensuring complex offshore activities are carried out safely and efficiently. Their importance is clear in daily operations. These vessels handle transport, installation, maintenance, and logistics, supporting the continuous functioning of offshore infrastructure in challenging marine conditions. As a result, wind farm support vessels are essential for maintaining reliability and efficiency in offshore wind energy production, forming a key link between technology, operations, and sustainable power generation. Offshore wind energy has expanded rapidly, driven by stronger and more consistent wind conditions at sea. Compared to onshore sites, offshore locations offer higher efficiency and greater energy output, while allowing larger installations without land constraints. This growth brings increased operational complexity. The construction and operation of offshore wind farms require detailed planning and coordination across multiple stages. Specialized vessel support is therefore essential. Wind farm support vessels provide the logistics for installation, operation, and maintenance, ensuring turbines and infrastructure function reliably in demanding marine environments. As a result, these vessels are critical to the success of offshore wind projects, enabling efficient execution and sustained performance throughout the wind farm lifecycle. Offshore wind farm operations rely on a diverse fleet of specialized vessels, each designed for specific tasks that support efficient construction, maintenance, and power transmission. Wind turbine installation vessels are central to construction. Equipped with heavy lift cranes, large decks, and dynamic positioning systems, they transport and install foundations, towers, nacelles, and blades, requiring precise coordination to avoid delays and cost increases. Service operation vessels provide ongoing support. Acting as offshore maintenance hubs, they remain at sea for extended periods, offering accommodation, workshops, and logistics while maintaining position near turbines for efficient inspections and repairs. Crew transfer vessels ensure daily mobility. These high-speed units transport technicians and light cargo between shore and turbines, enabling timely maintenance and rapid response under varying sea conditions. Cable-laying vessels support energy transmission. Using specialized systems, they install and protect submarine cables that connect turbines and link wind farms to the onshore grid. As a result, each vessel type contributes to a coordinated system, supporting the full life cycle of offshore wind farms, from installation to long-term operation and energy delivery. Wind farm support vessels play a critical role across every stage of offshore wind development, from early planning to final decommissioning. Each phase requires different vessel types and capabilities to ensure safe and efficient execution. The process begins with site investigation. Survey vessels map the seabed and conduct environmental and geotechnical studies using tools such as sonar and sampling systems, providing data for foundation design and planning. This leads to the construction phase, the most resource-intensive stage. Installation vessels assemble turbines, cable-laying vessels install the electrical network, and service operation and crew transfer vessels provide logistics, moving personnel and equipment across the site. During operation, continuous vessel support is essential. Service operation vessels act as offshore bases, while crew transfer vessels ensure regular access for maintenance, inspections, and repairs. The final stage, decommissioning, also relies on specialized vessels. Heavy lift units dismantle turbines, remove cables and foundations, and transport components back to shore with minimal environmental impact. In this way, wind farm support vessels enable the full life cycle of offshore wind farms, ensuring efficiency, safety, and reliability from initial surveys to end-of-life removal. Technological advancements have significantly improved the performance of wind farm support vessels, enhancing efficiency, safety, and environmental sustainability in offshore operations. One of the key developments is dynamic positioning systems. Using sensors, GPS, and thrusters, these systems maintain precise vessel position even in challenging conditions, which is essential for installation, maintenance, and cable laying activities. This progress has also improved underwater operations. Remotely operated vehicles enable detailed inspection and maintenance of subsea infrastructure without divers, increasing safety and efficiency. Environmental performance is another focus. Hybrid and electric propulsion systems help reduce fuel consumption, emissions, and noise, supporting the sustainability goals of offshore wind energy. At the same time, communication and navigation systems have advanced. Satellite connectivity, radar, and integrated bridge systems enable real-time coordination and better situational awareness. In this way, technological innovation continues to strengthen the role of support vessels, ensuring safer, more efficient, and more sustainable offshore wind operations. Environmental considerations are central to offshore wind operations, with a strong focus on minimizing impact on marine ecosystems. Support vessels contribute by adopting cleaner technologies, following best practices, and complying with environmental regulations. A key objective is reducing greenhouse gas emissions. Hybrid and electric propulsion systems, along with low-sulfur fuels, help lower emissions, while optimized routing and reduced speeds improve fuel efficiency. This also includes managing underwater noise. Vessel operations can affect marine species, so quieter propulsion systems and noise reduction practices are increasingly used to limit disturbance. Responsible waste management is equally important. Modern vessels use systems for waste segregation, recycling, and treatment of sewage and bilge water to prevent pollution. As a result, protecting marine biodiversity remains a priority, supported by environmental assessments, mitigation strategies, and continuous monitoring to ensure sustainable offshore wind development. Wind farm support vessels are fundamental to the success of offshore wind farms throughout their entire life cycle, from construction to operation, maintenance, and decommissioning. Their specialized capabilities enable efficient and reliable offshore activities, even in harsh marine environments. This role drives continuous innovation. Advances in vessel design and technology reflect the evolving needs of the sector, improving efficiency, safety, and environmental performance. At the same time, their broader impact is clear. These vessels support economic growth through job creation and industrial activity, while contributing to energy security by enabling large-scale renewable power generation. As a result, wind farm support vessels remain central to the transition toward a low-carbon future, supporting sustainability goals and global climate efforts.